Okay, so today we're going to talk about parallel and perpendicular lines and horizontal and vertical lines. So we're going to start with parallel lines. Parallel lines have the identical or same slope. So they look something. Oh, what happened? There we go. So it looks something like this, right? They go on forever and then they never touch. So they have the identical or the same slope. So this first thing says determine the slope of a line that's parallel to a line with a slope of 5. Well, if it has a slope of 5, the parallel slope would also have a slope of 5. The slope of a line that's parallel to a line with a slope of -2/5, this would also have a slope of -2/5. Parallel to a line with a slope of 0 would also have a slope of 0. And then the parallel to a line with an undefined slope, that would also be undefined. They're going to have the exact same slope if they're parallel. So, determine the slope of a line that's parallel to the below line. So what we're doing is we're trying to find what the slope of the original equation is. So remember that it is y equals mx plus b. So this m right here, that is the slope. So that's what we're looking for. So in this first equation, it's y equals 3x plus 7. My slope is 3. So the parallel slope would be 3. So I put m equals 3. So that's my slope. Second one, y equals -2x. That slope is -2. So my slope would be, -2. In the third equation, y equals -2/3 x minus 5. The slope is -2/3. So the parallel slope would be -2/3. The next one, y equals x plus 2. Well, there's an understood 1 here. It's like 1 times x. So the slope would be 1. And the next two are a little bit different. Y equals 5 and x equals -3. These are not in the y equals mx plus b form, so you can't really find the m here. So as a reminder, when you have y equals something, that means that it's a horizontal line at 5. And horizontal would have a rise of 0 and a run of whatever, of some number, of some constant. 0 divided by any number is 0. So the slope would be 0. In a different way, x equals -3. That's a vertical line at -3. And that has a rise of some number. Rise of some number over a run of 0. And so if you take some number and divide it by 0, you can't do that. Like, you can't take $5 and split it amongst 0 people. So that is undefined. So draw a line that's parallel to the given line that goes to the point 0, 0. So I'm going to start with the point 0, 0, right? It has to go through there, so I know that that's a point. Now the slope on this first line is a rise of 2 and a run of 1. So I go from one point to another. I went up 2 and right 1. Those are both positive. So 2 over 1. It's going to be the exact same thing if it's parallel. So I'm going to go up 2 and to the right 1. Up 2 to the right 1. Up 2 to the right 1. And that's my parallel line. So next we're going to determine if the lines are parallel or not. So basically we're just seeing, okay, are the slopes exactly the same? So this first one has a slope of 3. Second one has a slope of -3. 3 and -3 are not the same, so these are not parallel. The next example, -2/3 x plus 9. That has a slope of -2/3. And y equals -2/3 x. I'm just comparing those slopes. I don't care about the y-intercept at all. So these are parallel because -2/3 and -2/3 are exactly the same. Now this next example, I don't know the slope. It has to be in y equals mx plus b. So I have to solve for my slope first. So I'm actually going to solve for the slope in the second equation first because it's a little bit easier. So I have y equals 6 over 4x plus 12 divided by 4 is 3. And 6 divided by 4, that simplifies to 3 halves. So this is y equals 3 halves x plus 3. So this second equation has a slope of 3 halves. So I just have to know, does this other one have a slope of 3 halves? So let's find out. So I have 3x minus 2y equals 8. I have to solve for y. So I'm going to start by subtracting 3x from both sides. So I have negative 2y equals negative 3x plus 8. And then I'm going to divide everything by negative 2 so that it cancels out. And negative 3 divided by negative 2 is 3 halves x. And then 8 divided by negative 2 is negative 4. So this also has a slope of 3 halves. So I have a slope of 3 halves and a slope of 3 halves. So these are parallel. This last set, y equals 8 and x equals 8, we just went through what those slopes are. But as a reminder, right, if I were to draw this, y equals 8 would be something like this, a horizontal line at 8. And x equals 8 would be a vertical line. So just by looking at this, these are not parallel. But one has a slope of undefined and one has a slope of 0. So that should also give you an idea. Perpendicular lines have negative reciprocal slopes. So perpendicular lines look something like this. They are two lines that come together specifically at a right angle. They don't have to look like the coordinate plane, though. They could look like this as well. But they come together at 90 degrees. So if one slope is negative, the other one's positive. And then horizontal lines horizontal and vertical lines are perpendicular to each other. So one has a slope of 0, and the other slope would be undefined. So can you come up with example pairings of slopes that would be perpendicular? So some examples would be like 2/3 and negative 3 halves. So one's positive, the other one's negative, and you also flip that fraction. Or negative 1/2, and then that's negative, so the other one would be positive. And if I flip that fraction, it becomes 2 over 1. Or 2. So if I were to go the other way, if I had like 3, the opposite would be negative. And then remember that 3, written as a fraction, is 3 over 1. So if I flip that fraction, it's 1 over 3. So 3 and negative 1/3. Those two slopes would be perpendicular to each other. So we're going to determine the slope of a line that's perpendicular to the following. So this first one, 3x plus 7, has a slope of 3. So the perpendicular slope would be negative 1/3. And again, remember, 3 is the same as 3 over 1. So you have to flip that fraction. Similarly, the next one has negative 2. So if I wrote that as a fraction, that's negative 2 over 1. So if I flip that, that becomes 1 over 2, and it's going to be positive. Next, negative 2/3. So the perpendicular slope is going to be positive, and I'm just going to flip the fraction of 3 halves. The next one has a slope of negative 1/4. So its perpendicular slope is going to be positive, and I flip that fraction, which would be 4 over 1, or just 4. Next, that slope is 1. Okay, so that's 1 over 1. Same thing. So my perpendicular slope would be negative, and if I flip that fraction, it's still 1 over 1, so it's just 1. Y equals 5. Remember that that is a horizontal line at 5, which has a rise of 0 and a run of some number. So it has a slope of 0. So if I flip that, it's going to become negative some number over 0, which is undefined. Can't take something and divide it by 0. Also, we said that horizontal and vertical lines are perpendicular to each other. So similarly in this next one, x equals -3. If I drew that, it's a vertical line, which has a rise of some number and a run of 0. So that actually has a slope of undefined. So the perpendicular slope would be 0. So we're going to draw a line that's perpendicular to the given line that goes to the point 0, 2. So I'm going to start with the point 0, 2, which is right here. Now the slope of this line is a rise, again, of 2 and a run of 1. So it has a slope of 2, or 2 over 1. So the perpendicular slope, we write perpendicular like this, like upside down T, because it shows a 90-degree angle. Perpendicular slope would be -1/2, which means I'm going to go down 1 and right 2. So from 0, 2, I'm going to go down 1 and right 2. Down 1 and right 2. So my perpendicular line looks like this. So now we're going to determine if these lines are perpendicular or not. So my first line has a slope of 3. The second one has a slope of -3. Those are opposites, but they're not reciprocals. It would have to have a slope of -1/3. That would be the perpendicular slope. So these are not perpendicular. The next one has a slope of -2/3, so the perpendicular slope would be positive, and if I flip that fraction, it becomes 3 over 2, which is what I have. So these are perpendicular. Now the next set, again, it's not solved for y, so I don't actually know what the slope is here. So let's see here. I've got 3x minus 2y equals 8. I have to solve for y. So I'm going to subtract 3x on both sides. So I have -2y equals -3x plus 8. And I'm going to divide everything by -2. So I get y equals -3 divided by -2 is +3/2 x, and then 8 divided by -2 is -4. So this has a slope of 3/2. Now I'm going to do the next one. 2x plus 3y equals 12. I'm solving for y, so I'm going to subtract 2x. So I have 3y equals -2x plus 12. And then I have to divide by 3. So I end up with y equals -2/3 x plus 4. So the slope there is -2/3. So one is positive and one is negative, and they are reciprocals. So 3 divided by 2, if you flip that, becomes 2/3. So these are parallel. And then this last section, y equals 8 and x equals 8, one is horizontal, one is vertical, so they are parallel. Or sorry, perpendicular. I don't know why I'm saying parallel. They're perpendicular. Oh, and I said parallel down here. I meant perpendicular. All right. So a review of horizontal and vertical lines. So vertical lines are written as x equals a constant, vertical lines have undefined slope, and x values are all the same. So there is this thing you may or may not have heard, which is Vux-Hoy. So let me show you what that is. So the V, that means vertical line. The U is the undefined slope, and the X is the X equals. It's this X equals. And then the Hoy is the same idea. So you've got horizontal lines a slope of 0. So like the O is a 0, and then this is, y equals is the y in the hoi. So some people really like that because they just like those mnemonic things, but Vux hoi is helpful to remembering that, if that's helpful. So we're going to graph these lines. Y equals 2. Well, that is a horizontal line at 2. That's that one right there. X equals -3. That's a vertical line at -3. Horizontal line through 3, 4. So let's look at that. So the point 3, 4 is to the right 3 and then up 4 right there. And so that horizontal line looks like this. Vertical line through 3, 4 is the same point, but the vertical line goes up and down. And then a line through 0, 6. I'm going to put that point there. That's on the y-axis. That is perpendicular to x equals 7. Well, the line x equals 7 would be a vertical line. So this is the perpendicular line would be horizontal. All right, write the equation of these lines. Horizontal line, that's that. So, yeah, Vux hoi, right? Horizontal line is y equals. This is going to be y equals that y value here, 5. And a vertical line, that's the v in the Vux hoi thing, of x equals what the x value is, which is 1. Line through 2, -7, that's parallel to x equals 5. Well, that means that it has the exact same slope, which means that it must also be an x equals, and it must be this 2 here. And a line through 2, -7, that's perpendicular to x equals 5. Well, if it's x equals 5 and it's perpendicular, that means that it must be a y equals the y value, which is -7.